See, actually, we spoke about modulation. Okay, so at that time you told that by with the use of pi by 2 BPSK you can reduce. Okay, so at that time I told how that PAPI it will come to picture first. That you have to understand. Okay, so from then you have to take off.
Yeah, so as I understand, your question is, let me go one by one. So first we'll talk about the PAPR definition. Okay. So, so you're able to see the screen?
Yeah, it's visible. See, we are used to this one because actually we done the classes for almost 2 years. That pandemic was happening, right?
Hmm. Yeah, so the PAPR definition. So PAPR is peak power to average power ratio, right? So this is peak power, and this is average power. So first, now we will talk about the PAPR of a BPSK system. Okay, so BPSK system we need to take the reference. So let's take, I will take the constellation something like this. Okay, let's say this is 1 and this is minus 1. Of course, minus 1 comma 0 and 1 comma 0. Now let us take 4 IQ samples. Okay, um, which means for example, this is a modulation block, right? So this is the modulation block. For example, input to this modulation blocks are let's say bits. I am taking 4 bits. So here we output we will get complex IQ values. But here these values are going to yield me real only. So how can I write my 4 values? So as per this, let's say 0 bit 0 is mapped to this one. Let's say bit 1 is mapped to this value. So for this one, then what I will get minus 1, right? Minus 1 comma, then 1 comma, minus 1 comma, minus 1. All right. So now PAPR calculation. So for that first peak power. So in these 4 samples, what is the peak value? 1. Okay, let us take 1, or in the negative direction minus 1. So it is like basically a mod of 1 or minus 1 square, which will be 1 only. Okay, let's take average power. So how to calculate our average power?
So square of all the values divided by 4.
Yeah, 4 into all the values, it will be 4 only. So which is equal to again 1, correct?
Yeah, correct.
So this 4, how it has come, like minus 1 whole square plus 1 whole square plus minus 1 whole square plus minus 1 whole square, right? So now what is
Correct,
the
correct.
PAPR?
PAPR is 1.
1, right? So you understood. So now the next point is in the OFDM system. Okay, how PAPR is increased. So we will take OFDM, and again we will take the same modulation scheme, which is BPSK. Okay.
Okay.
So so uh, so after this modulation block, which is 1011, this is a modulation block, and we have this what do you call? We have this IF50, right? For OFDM system, we do IF50, correct? So these two operations are there. So at this point, we need to see how does my samples look like, and for that we need to take the this one. So at this point, um, what are my values? My values are minus 1, 1, minus 1, minus 1. Okay. So now IF50 we need to do. So let us take some simplistic value. So this is so okay, I have taken 4 samples, right? So since I have taken 4 samples, I have let's say I am going to do 4-point IFFT. So for the sake of simplicity, what I will do is yeah, I will do what I will do. I will in the previous BPSK system, I will take all our zeros, for example. Okay, just for sake of understanding, all our zeros means this one, all are 1 1 1 1. Correct? No, all are ones, which means anyway we will get all are one means these are all plus plus. So anyway we will get same PAPR. You agreed?
Yeah, correct.
Now for OFDM system, I will again take all are ones. Sorry, here it is all are zeros, right? I have taken zeros, which means at the output I will get all ones, plus 1 1 1 1. So 4 point, this is 4-point IFFT I need to do. Okay, so how does my IFFT look like? 4-point, so I am writing a 4-point matrix. Is this correct? Wait a minute.
Yeah,
I will.
So it will be what? Summation of x of n e power minus j 2 pi n is 4 into n.
Minus 1, then we get j minus 1 j. See, this is 4-point IFFT. Okay, IFFT or FFT you can think. So then I have all 1 1 1 1 samples. So if I do this operation, matrix operation, what do I get? So all 4 4 I will get 4. Okay, then this one will become 0 0 0. Okay, so that you can calculate, but this is how it looks like. So at this point we will get 4 comma 0 0 0. Okay, so if you want to write the actual OFDM equation, then it will be like 1 by square root of 4 actually, which is 1 by square root of n. Okay, as per the equation. So 1 by square root of 4 you can take. In which case you will get square root of 4 comma 0. So in which case you will get square root of 4 comma 0 comma 0. Now this is the now we have this one. Okay, so what is the peak power? So peak power is this one.
Peak power is yeah, square.
4.
Square root of 4 is 2. 2 square means 4.
Right. Okay. Average power.
Average power is 2 square 4 divided by 4 1.
1. So what is the
2 square by 4? Number of sample is 4. It's 1.
PAPR?
PAPR is 4.
Yeah, right. So PAPR is 4. In general, this is actually n point, right? N is equal to 4 we had taken. So this will be n for a OFDM system. So for a normal single carrier BPSK system, okay, our PAPR value was equal to 1. But whereas for OFDM system, which is a multi-carrier system, right? Multi-carrier system, my PAPR is n. How much ever times of IFFT we do, that will be the value. So you can clearly see right now, no, that for a OFDM system the PAPR is increased. So this is understood.
Okay. It's increasing because of more number of subcarriers.
Correct. So now I will start what happens in case of DFT-s-OFDM. Okay. So it is claimed that in DFT-s-OFDM the PAPR is reduced. Okay, let us see how that is reduced. first we need to write the block diagram, okay, for DFT-s-OFDM. Normally we had what? Normally we had, I had taken all zeros, right? So this is a modulation, the DFT block. So it will be like M point DFT. Then for OFDM, we have N point, IFFT block will be there, right?
Yeah, correct.
See, usually, in DFTs OFDM, M will be less than N. Okay, so for now, our simplicity, what we will do, this will take 4 point, this will take 2 point. Okay, so now let us say, it has got only just two values. So in this case, what happens? We need to see, what are the values as per our, this is a BPSK, right? As per that, the values, the samples are 1 and 1. These are IQ samples. Next to M point DFT, right? How does a 2 point DFT matrix look like? So 1, 1, 1 minus 1, right? And my input is 1, 1. So if I do, how much do I get? Let's say even if I take 1 by square root of 2 as a normalization factor, then it will be square root of 2 and 0. Correct? So at this point, I have square root of 2 and 0. Now this is input, and we need to perform 4 point IFFT. Okay. Then of course we need 4 point, but what we have is minus square root of 2 and 0. So one more thing, what we need to what we need to observe here is, so this one, if you take 2 point DFT at this point, if you see the just spectrum, you see, okay, at we have square root of 2, and then actually we have one more point which is 0, which means my spectrum is something like this, right? So there is a certain place where the peak is very high, and there is a certain place where we have low values. This will have more signal variations. Okay, but if we so if we spread this signal and ensure that if the signal variations are less, then we can ensure that the PAPR is less. So let us see how it will be seen after the IFFT operation. Okay, so I will take here, my input is square root of 2 comma 0. I will do some 0 padding, okay, because we need 4 point. So finally I have 4 points to this IFFT block, which is a 4 point. So let's say I will put zeros on either side and square root to 0. Okay. So again, what is my 4 point DFT equation? So this is how it is, right? 1 and minus j. Then my input is 0 square root of 2, 0, 0. Okay. So then what is the output? So output is square root of 2. Okay, let us take a normalization factor also into picture. I will say I have written it here. Now square root of 2, then minus j square root of 2. Then what about this one? Minus square root of 2. And j is again j is again what? J into square root of 2. Okay. Now, how does my power look like? Okay, here almost all of them has the same magnitude. So peak will be peak power will be 2 if you take any of the value, and let's say for now this normalization, okay, 1 by 4 into 2 will be the peak power. Then average power will be, we have 4 samples, and each of the sample Each of the samples are
Okay,
almost
2
at
by
the
4
same
only.
magnitude. 4 into that much, 2 into 1 by 4, correct? So 4 gets cancelled, and this numerator and this denominator get cancelled. It is equal to almost 1. It is almost equal to, in this particular example, the PAPR is almost equal to the BPSK system, right? So what is the comparison? The comparison is that, so single carrier BPSK, it was equal to 1, and then the OFDM, when we did to the BPSK system, we got N, which is actually in our case 4. But so we wanted to see if we do DFT-s-OFDM, then this value will become less. So in this case, for our example, we had seen it is just 1, right? So basically, if we draw the spectrum of this, okay, this one, power spectrum, then how does it look like? So power spectrum will be, the first value is uh, 2 by 4, which is half, right? Half. Even the other power is also off. All powers are off, actually. Correct. So if you see here, the signal variations are less. That's what happened, right? Because in the earlier case, when we had, if after doing DFT, we saw that the signal variations are more. Like the first sample was having a power of 2, the second sample almost it went to 0. So here the variation was, signal variation was high. So whereas in this case, we are seeing that once we do the power calculation, we are seeing that power spectrum where signal variations are less, and hence we expect here that the PAPR is reduced, and as per our mathematics also, the PAPR is reduced. So now I think you got the concept, how DFT-s-OFDM is reducing the PAPR, right?
Actually, I came to know how that PAPR is coming to picture, firstly. Secondly, so PAPR, if it is more, okay, how you can bring it down to less value?
Correct,
Okay,
correct.
so I mean, if the signal variation, if you make the signal variation such that it happens to have less fluctuation,
Hmm.
then the PAPR will be reduced. This I have understood.
Hmm.
By having this one, I will go forward. Again,
Hmm.
if I have any doubt, I will get back to you. Okay.
Yes, okay.
Okay.
Okay,
You
great.
kindly send me this PPT so that it will be needed as a reference.
Okay, sure.